Assalamualaikum warahmatullahi wabarakatuh to our lovely panels and beloved audience. I am Muhammad Alham Sodiq bin Alimuddin and my supervisor is IR Dr. Amirul bin Abdul Rashid. I am a final year student from College of Mechanical Engineering, and in this video I will present my final year project proposal entitled Stair Climbing Wheelchair Design. Moving on to the first slide, which is the introduction. What is a wheelchair? A wheelchair is a walking aid device. However, there is a limitation in the mobility of the standard wheelchair to going up and down the building without the help of a lift, especially during an emergency. Therefore, a lot of researchers have come up with a solution to propose a new design concept of a wheelchair with the ability to climb a stair with the help of advanced technologies throughout the past few years. According to M. Jalon, 2003, the first commercially produced stair climbing wheelchair became available in Japan is on mid-1990s. There are several commercial stair climbing systems on the market, but most of them are complicated, extensive, heavy, costly, and need many sensors and actuators based on CATIA 2017. Therefore, the different proposed mechanisms such as track, leg, wheel cluster, and hybrid methods have their specific features and disadvantages. The next part is the literature review. According to M. Jalon, ascending a flight of stairs offers two significant challenges. First, climbing each step, and second, maintaining the stability for the whole system while on the steps. To counter the problems, one of the parameters that need to be concerned is the mechanical design of the wheel or leg. Cluster wheel is one of the mechanisms used in stair climbing operation of previous study. The study in Gigoglia 2015, they use a locomotion unit comprises a triangular frame with an internal epicycloidal mechanism connecting the input gear to each wheel connected to the planet gears. What is epicycloidal? Epicycloidal mechanism is an epicyclic gear train consists of two gears mounted so that the center of one gear revolves around the center of the other. The Willis equation is used to determine the gear ratio of the epicycloidal mechanism. However, they also states that using this rotating leg locomotion can reduce the user's comfortableness when climbing the stair wheel structure. The oscillation of the wheelchair is caused by the employment of a spinning leg movement as the locomotion unit's center follows a cycloid-like trajectory during the steady state step climbing. The next system for stair climbing is the track. The single and dual section track operation introduced in M. Jalon in Nagasaki, Japan. Dual section track is a two shorter track segments take the place of a single centrally pivoting track. This structure provides an adjustable rear wheel track that can adapt to different angles and dimensions of stairways. This states that the benefit of this strategy are that it allows the vehicle to begin and finish the stair climb in a such strategy that it makes touch with more significant number of stair edges or surfaces and avoid the instability. The advantages of this method are the operational independent steps, curbs, and slopes encountered. Moreover, the track-based concept also provides static stability and prevent the wheelchair from overturning in Gigoglia 2017. The problem related to stability may be influenced by the configuration of the wheelchair mechanism structure. According to Gigoglia 2017, the friction force on the wheel must be almost equivalent to the track contact force horizontal component to prevent slippage of the wheelchair. Therefore, placing the track wheel at the rear improves the stability as well as the safety during the steady state climbing. Moving on to the third part, which is the problem statement. One accessibility issue that the standard wheelchair users confront is navigating stairs. However, a minority of disabled people cannot own a stair climbing wheelchair, especially in developing countries due to the cost of the technologies. Moreover, the need for this device is beneficial in an emergency where no lift in the building area. Therefore, instead of paying the wall motorized stair climbing wheelchair, an affordable universal wheelchair adapter that can attach to any current standard wheelchair is needed. Next is the objective of this project. The first objective is to design a motorized stair climbing universal adapter for the the standard wheelchair. Second is to study the efficiency of the track wheel mechanism concept, and lastly, to compare the mechanical design concept of the previous study. Next is the scope and limitation of the project. The primary goal of this project is to design an universal stair climbing wheelchair adapter that is compatible with all regular wheelchairs. CATIA V5 is the software used to create the mechanical design and concept for finite element analysis. By doing an analysis on certain load, the appropriate size and material may be determined. The analysis outcome will decide the mechanical design's efficiency. Moving on to the methodology. This is the flow of project methodology. First is to gather information from the article reviews, then identify and compare the type of mechanism used in the previous study. Next, using a CATIA V5 software to create a 3D model of overall design and also the critical part. After design process, the important part of the design must undergo the strength test through finite element analysis in CATIA V5 software. And lastly, assemble the design part. The table shows the summary of some existed motorized stair climbing wheelchair mechanism concepts of previous study. Each method approaches the different climbing procedure. This method is to identify and compare the previous existed mechanism that has been proposed. Next is the decision matrix. This method is to evaluate and select the best option from several types of mechanism design. This tool is especially beneficial in this case, and there are several aspects to consider before making the final choice. As seen from the table, the track-based mechanism has the highest score. The simplicity majority contributes some points because the track has the easiest to understand the working principle in order to adapt it to the overall design. Lastly, 3D modeling and finite element method. The wheel holder is one of the critical structural parts of the whole design. The weight of the wheelchair and the rider relies on this part as it holds the bottom part of the wheelchair. The material used for the wheel holder is aluminium. The overall weight used in the test is 160 kg, about 1568 Newton, which is the estimated weight for a standard wheelchair and the person on it. The distributed force is applied using two axes, which is tilted about 45 degrees to the ground based on the position of the wheelchair during the climbing the stair. This application generates and collects aggregated outcomes for further action. The last part is the expected result. As seen in the left figure, the maximum von Mises stress in the core is 223 MPa, which is less than the material's yield strength of 97 MPa. Furthermore, as seen in the right figure, the core's most significant displacement is about 0.515 mm, and the deformation is relatively tiny. As a result, the core is sufficiently strong, the structure is stable, and the overall design is rational. That's all from me. Thank you.